Welcome to The Explainer. Today, we're diving into the absolute magic behind fluid power and industrial shock absorbers. So, how do you stop a massive, speeding object without causing total destruction? The secret's in fluid dynamics. Okay, let's dive into this. The complex internal anatomy you see here reveals a brilliant engineering secret. Basically, a shock absorber uses fluid to cushion heavy impacts, safely absorbing the kinetic energy of a moving mass. Non-regenerative shocks just dissipate energy, but regenerative ones, they smartly use stored power to return right to equilibrium. Let's kick things off with our first type, hydraulic heat absorbers. When a mass strikes, it drives the piston inward. Instantly, resisting fluid pressure slams the check valve closed. Now what's really interesting here is how blocking those orifices creates increasing resistance, smoothly decelerating the mass. All that violent kinetic energy, it's completely converted into harmless heat energy that simply dissipates away. Moving right along, let's look at hydropneumatic shock absorbers. The big difference? Standard hydraulics only use liquid, but hydropneumatics actually introduce a gas into the mix. Gas compression brings the massive weight to a halt. Then, that gas expands, automatically resetting the entire mechanism. So, the crucial point is understanding the fluid properties that actually make all of this possible. Engineers have to perfectly balance three vital fluid traits: bulk modulus, density, and viscosity. A high bulk modulus means the fluid firmly resists compression, stopping unwanted energy storage and dangerous springback. Using higher density fluids allows for shorter physical stroke, but it demands much higher internal working pressures. Viscosity controls flow speed. Lower viscosity means faster strokes, but it must remain absolutely stable across extreme temperatures. Finally, let's talk about a fascinating regenerative concept: liquid springs. Unlike the others, these completely rely on a highly compressible liquid to forcefully push the ram back. And this brilliantly illustrates their power. Just one liquid spring equals the load of 30 standard coil springs. But they aren't perfect. They need massive initial loads, cost a fortune, and have severe pressure sealing challenges. All right, let's step back and summarize everything we just covered about fluid power and rapid deceleration. Heat absorbers just dissipate energy, whereas hydropneumatic and liquid springs actively use compressed fluids for return forces. Remember, orifices turn energy to heat, gas adds return force, and bulk modulus dictates the energy storage. Next time you see heavy machinery stop perfectly smoothly, ask yourself, how exactly is that kinetic energy transforming?
We appreciate your time today. Elevate your expertise daily with precise, actionable insights. Support our mission for continuous learning by engaging with the community below.